Okay guys, today we're going to finish out talking about pyramids, and we're going to conclude with the volume of pyramid. So before we actually get into formulas and such for volume of a pyramid, we do need to talk about one thing, and that is the height of the pyramid, because earlier when we were talking about surface area, we talked about the height of the triangular face, or the height of the lateral face. But now with volume, we're actually dealing with the height of the pyramid, okay, and that is going to go from the apex or the vertex here all the way straight down, and it's going to kind of look like it's hanging out in the middle of nothing here, okay, just kind of there. That's actually going to the center of the pyramid, of the base, okay. If we look at the rectangular pyramid up here, okay, it's got a rectangular base, and then the height is dropped down straight from the vertex point here all the way down, and it, like I said, it looks like it's kind of in the middle of nowhere. If we look at the triangular pyramid, that's where things might get a little crazy, because not only do we have to deal with the height of the pyramid, okay, which is again coming down from one of the vertexes straight into the center, it looks like, of one of the faces, but we also have the height, or the slant height, of the triangular face, the lateral face, that is here. And I can't say they won't ever be kind of on the same face, but most of the time they're going to be separate, kind of like this one is here, so you could really tell. You could see the red one is just kind of in the middle of that triangular face, while the green one comes and is perpendicular to this base of this triangular face right there. So try to be observant of which is the height of the pyramid and which is the slant height, or the height of the lateral face. Alright, so when we're talking about volume, the formula we use is 1/3 the base of the pyramid times its height. Okay, so for a rectangular pyramid, it would be 1/3 the length times the width times the height of the pyramid. For the triangular pyramid, that's where things again get a little more interesting, because you have the two heights. So you find the area of the base of the triangle, or the area of the triangle rather, and then multiply that by the height, and then do 1/3 of that. Okay, and just in general, the formula for a pyramid is 1/3 the big B, which is the area of the base, times the height. So for an example, we'll start off with a rectangular base pyramid. Okay, we have a side length of 6, a side length of 8, and then a height of 9 feet. So we find the area of the base, so 6 times 8, which is 48 feet squared. And then we take 48 and multiply that by 9, which is the height of the pyramid. And we get 432 feet cubed. From there, we need to find 1/3 of that. So we can multiply 432 by 1/3, or divide 432 by 3. Either way, we're going to come up with 144 feet cubed. And then the last example we have is working with a triangular based pyramid. Okay, so first we have a base here of 8, base length of 8, and then a lateral height, or a slant height, of 5. So we find the area of that triangular face. So 8 times 5 is 40. Divide that by 2 is 20. So that would be 20 meters squared. We then take our 20 meters squared and multiply it by the height of the pyramid, which is 7.5. So 7.5 times 20 leaves us with 150 meters cubed. From there, we need to take 1/3 of that. So 1/3 times 150 leaves us with 50 meters cubed. Well, that's it for volume of pyramids. We're going to practice this in class, and we'll see you then. Os.